You would not have seen anything weirder than a black hole. These are regions in space where the gravity is so strong that nothing can escape them. If someone fell into a black hole that was left over when a star died, they would be shredded. The massive black holes seen at the center of all galaxies have insatiable appetites, and here, laws of physics do not matter. Stay till the end to know whether one can survive falling into a black hole. Most of the time, black holes are inactive, but when they are active and each star is in gas, the region close to the black hole can outshine the entire galaxy that hosts them. Quasars are the galaxies where black holes are active. There are plenty of mysteries related to black holes that are not solved yet. Black holes are expected to form when a massive star dies and after the star's nuclear fuel is exhausted. The core collapses into the densest state of matter imaginable. It is probably 100 times denser than the atomic nucleus. The black hole is so dense that protons, neutrons, and electrons are no longer discrete particles. Black holes are dark, and they are found when they orbit a normal star. The properties of a normal star allow astronomers to infer the properties of its dark companion, a black hole. Cygnus X1 was the first black hole confirmed by scientists, and since then, about 50 black holes have been discovered in systems where a normal star orbits a black hole. Around 10 million black holes are scattered throughout the Milky Way. These are tombs of matter and nothing can escape them, not even light. The fate of anyone falling into a black hole would be a painful spaghettification, an idea popularized by Stephen Hawking in his book A Brief History of Time. According to this idea, the intense gravity of the black hole would pull you apart, separating your bones, muscles, sinews, and even molecules. Do you know why scientists couldn't imagine the black hole as an object? Even light can't escape the gravitational pull of a black hole, and there are no photons that are reflected which can be used to image the black hole as an object. After all, it is called a black hole for a reason. It is possible to detect them, and astrophysicists use proxies like the stream of matter and energy pulled from a ripped-apart star. The gas molecules start swirling around the black hole in the form of a disk and emit powerful X-rays. In April 2019, a huge collaboration of international scientists captured the first picture of a black hole. They imaged the black hole's event horizon, which is the point of no return. The image was constructed from data gathered by observatories globally, which were combined to create a virtual telescope as big as the Earth. Virtually every galaxy has a supermassive black hole that is typically millions of times more massive than the Sun. Moreover, our local black hole is located in a region known as Sagittarius A that lies around 26,000 light-years away from the solar system. It is about 4 million times the mass of the Sun, which is about 1 million times more massive than the Earth. According to ESA's Herschel Space Observatory, molecular gas is heated at 1,000 degrees Celsius up to 1 light-year away from the Milky Way center, which is way much hotter than typical interstellar clouds, which are usually only a few tens of degrees above the minus 270 degrees Celsius of absolute zero. Suppose you wear a spacesuit that would make you immune to the gravitational pull of a black hole. You might see objects passing through the black hole's event horizon to slow down and then freeze in time as if they have never passed through the event horizon. This is because the space-time is distorted, and the light takes longer to reach your telescope's glass. The light becomes dimmer as its wavelength becomes longer, eventually disappearing from the sight of the observer as it becomes infrared radiation, then radio waves. Black holes can grow indefinitely because anything that enters the event horizon gets sucked in. Some evidence suggests that ultramassive black holes found in the cores of some galaxies never seem to exceed 10 billion solar masses. Black holes don't grow beyond this mass because then they would begin to disrupt the accretion disks. A wormhole is a sort of theoretical tunnel through space-time, and it is often used as the preferred mode of interstellar travel in movies like Star Trek. It is also said to be an opening through intervening space to another location in the universe. Some physicists claim that several characteristics of black holes and wormholes are the same. They even claim that a wormhole is a black hole and vice versa. This universe that we are living in might have been created by a black hole. Billions of black holes in the universe might have spawned their versions of the universe. Over the past 30 years, observations with the Hubble Space Telescope have shown that all galaxies have black holes at their centers. Bigger galaxies have bigger black holes. Nature created black holes over a vast range of masses from a dead star. Some of them even turned out to be a few times the mass of the Sun. Last year, astronomers published the first ever picture of a black hole and its event horizon, a 7 billion solar mass beast at the center of the M87 elliptical galaxy. It is over 1,000 times bigger than the black hole in our own galaxy, whose discoverers might get this year's Nobel Prize. These black holes are dark most of the time, but when their gravity pulls nearby stars and gas, they propel out a huge amount of radiation. Black holes that are greater in size are dangerous in two ways. If you get too close, the enormous gravity will suck you in, and if they are an active quasar phase, you'll be blasted by high-energy radiation. The biggest black hole weighs around 40 billion times the mass of the Sun, or 20 times the size of the solar system. The outer planets in our solar system orbit once every 250 years, whereas a black hole spins once every 3 months. The outer edge of black holes moves at half the speed of light. Even the biggest black hole is shielded by view by an event horizon. At the centers of the black hole is a singularity, a point in space where the density is infinite. It is a one-dimensional point where a huge mass is squeezed into an infinitely small space. According to an American physicist, Kip Thorne puts the singularity is the point where all laws of physics break down. Scientists could not understand the interior of a black hole because the laws of physics break down. Time freezes at the event horizon and gravity goes to infinity at the singularity. Besides, several people believe that black holes act as a huge vacuum cleaner. It is true that black holes can pull matter inside them, but it is all due to the gravitational pull. If you replace the Sun with a black hole of equal mass, then theoretically there wouldn't be any changes in the solar system and everything will orbit as usual. Scientists have spent decades discovering every possibility related to black holes. The theory so far suggests that an object falling into a black hole becomes spaghettified. If you were to fall inside a black hole, you would be able to see distorted images as light bends around your point of view. The positive thing about falling inside a black hole is that you could survive there. As far as the gravitational pull of the black hole is concerned, it is much stronger there. However, the stretching force is weaker than it would be with a small black hole, and it would not kill you. The negative aspect of falling into a black hole is that the event horizon marks the edge of the abyss. Nothing can escape inside the event horizon. You will not be able to escape or report on your experience of falling into a black hole, so you would basically be lost forever. Do tell us your views in the comment section below about the possibility of survival in a black hole. If you have reached this far, like this video, subscribe to our channel, and press the notification bell so you don't miss any future updates. I'll see you in another video. Until then, take care.